Welcome everybody to Robot Builders Night Virtual for July 30th. As usual, we'll go around the table and talk robot related stuff. We have a few people that are going to present some updates on their projects, and then have an open mic where you can just add questions or just discuss whatever you're up to. As usual, we record these meetings, so if you don't want to be recorded, turn off your video and mute your audio. With that, we are going to take off. And to start us off tonight, we have Doug.
Okay. I wanted to discuss a little bit about Saturday's meeting. A bunch of us sat around and talked about how what type of presentations that we would like to have in the monthly meeting. And we said that what the conclusion was that they wanted to have some groups of people, but led by a clear leader on each project, and the other people would help, and they would report once a month as part of the meeting. There'd be, so not to try to give away it every week by week by week, because they said that week by week by week, the steps are too small. There's not enough progress, and they'd like to see it on the month. And they said they thought a really good example of one that was led, though it didn't need a team, and that was John when he did his URC. That was a good example of the type of stuff we would like to have. There were a couple of things that they suggested, and they said each of these projects should have a real clear objective. Okay. So one thought, okay, so we had a few that popped up, one was PID tuning, one was LiDAR, and then possibly SLAM, then the basics of ROS. But I know that Paul's given some things, but we're talking about something a little different. And so those were some of the basic ones. And also there was one to have a 2.5 hour robot build for a robot, basically a robot kit build that would be a 2.5 hour thing, and it would really be an outreach thing. So the PID, so what we said we'd want there is an actual practical demonstration. For example, a person would take the robot, put it on the table, and say, okay, here's how I'm going to tune this. And he would work absolutely through it, show that it was tuned, okay? The LiDAR on the first objective would be to show it being an effective object avoidance tool, okay? And then later in investigating SLAM. That's obviously a big topic and not one that's going to be very easy. But then the other one was the basics of ROS. And again, this was an idea, and the thought here was that Mike might be the leader in this group, and it would be an extremely simple thing, just a robot with teleop operation and a distance sensor. And he would take it from ground zero to that being a functional ROS robot. Okay, and let's see, what else? Huh?
Who would lead that?
Mike Wilson.
Oh.
He's not here, so that works for me. Now, but there's some ideas on that, and establishing the leaders for the individual ones probably needs to be talked about a little bit. And so now David Steele, which goes by the name of, here he is, he's Blue Steel here, suggested he would like to see an outreach program where we go out and build a specific robot, and it's called it Auto. Yeah, I'm sure you've all seen it. It's a little box that kind of walks like this. But the one he was showing was a little more complex than that. And so we would need somebody to figure out how to get the 3D parts, and how to put together the presentation. And we would open it up for the Dallas Makerspace or anybody in a club who wanted to build one. But limit it to either 6 or 10. We're not sure yet. It depends on what resources we can get together to actually source the robot. And it would be a 2.5-hour build. It's finished, and that's it. You know what I mean? So the idea is to maybe possibly interest some people in the club, probably from the Dallas Makerspace arena, and try to see how to build that. So that was pretty much the things that we talked about. We all exchanged junk. So I got some of Harold's junk, and some other people got some of my junk. So it was kind of cool. But and there were other people who had stuff here too. We picked up 2 new members last Saturday. Well, I shouldn't say that. 1 returning member and 1 new member. So that was good. And I had another returning member. His name is Mike Hernandez. Yeah, and people probably know Mike from way back. But the other one was was a relative of his, and I don't have his name right in front of me. But you can check the member list, and he's a junior, so you could go down the list until you found a junior, and that would be him. So anyway, that's what happened at the meeting. We had more pizza than we needed, but we had fun. It was good. So I was glad. I actually looked at a shelf and it had a space on it. I couldn't believe it. So it was a 6. Now the second item is this. This has been done. Can anybody see that? They probably can't. Let me present that. Our screen. This is the Robo Columbus 2024 mug that's going to be made and given out for the people. So can you see it? Is it available? I don't know. I can't.
Yeah, we can see it.
Okay. So anyway, this is 2024's. We're going with the theme this year of some retro stuff. You can see we're bringing Robbie into the picture. So anyway, that will be on the website later on tonight, probably. And this is the basic one that if you get a point or more, if you get 9 points, you get additional scripting on the mug. And if you do the 3 waypoint challenge, and I'm about going to suggest and add 1 more layer to our Robo Columbus Plus. So right now, you have 9 points. You go through three things, and you can pick up another point if you do the 3 cone challenge. That's where you have 3 waypoint challenge. And I'm also saying we're going to have another layer to keep the area growing on the top side, is that you have the no GPS challenge. So if you do it without a GPS, there's an additional point that you can get. So in theory, if you did the 3 waypoint challenge without a GPS, you could actually get a score of 11.
And Doug, I have an idea for an even harder level is to do the no waypoint challenge where the robot doesn't know where any of the cones are. That might be.
That's a little, my big problem with that is since we're talking about an area of, I don't know, 300 or 400 square, 300 on a side, a lot of space.
Yeah.
A person might have, and they can't see them from the home cone, or they can't see them from the target cone. So finding the challenge cone could be a real problem. But it's an interesting idea, Ted. We could possibly say you get a hint and then give a waypoint where you could see the challenge cone. Otherwise there's a single waypoint. So you'd have to use to go from home to target. You'd have to use your sight.
So
You'd have to find it.
I was thinking about something about that that would be really interesting, since a bunch of us have cameras that run models and or OpenCV stuff. If you have a human pose model loaded, you could literally have the robot facing you and point and say, the cone is over there.
Yeah.
And of course, it can look at your arm in the direction that it's pointing relative to what it's facing and figure out, hey, the cone is in that direction and the second cone is over there. And then it could go and find them. Now, that would be cool.
The problem with that one is that's actually specifically forbidden in the rules, because you can't get in front of it and it can't.
No. This is before you start.
Oh, I got you.
So when the robot is sitting at the home location, you say the first cone is over there and the second cone is over there, and then go.
Well, you should be able to see the first cone.
Yeah.
But you're right. Even with our cameras, you probably wouldn't be able to pick up a cone from 100 yards.
No.
But
if you know which direction roughly to go.
Let's play with this idea, because I think there's some merit there. I just not sure how we would actually implement it.
Yeah, I kind of like your idea, Doug, of giving the robot a waypoint where it can see each cone.
Yeah. But we'll see. Another thought, like I say, is, but we're definitely going to add one on the top, and that's the no GPS. Right.
I like it.
And the reason for that is a lot of people are going to be using RTK, which, I mean, that's like GPS on steroids. So we'll go the other way and just say, you're on Mars, dude. What are you going to do? So anyway, it's
the David Anderson challenge.
Yeah. So you're talking about a dead reckoning style, where you're not using.
Well, yeah, I guess. I mean, you'd have to, but that in David's case, he was always assuming you know where the cones are.
Yeah, you can do.
Okay, yes. I'm sorry, excuse me. Yes, I got confused about what we were talking about before.
Yeah,
you're right. With no GPS, it's a dead reckoning. So you're actually Columbus. You know what I mean?
Yeah.
And last time I was there competing with Robo Columbus, I had a dead reckoning robot.
Yeah. So,
Doug, I think that's kind of one way to view this. Is the whole point is the contest should set a target that we don't know how it's going to get met. It should be, let's see what people can do. This is a goal. We don't know what the implementation is. Let's not presume the implementation.
Yeah.
Okay. Well, so with what I'm seeing with the no GPS challenge, you do have 3 waypoints. Okay. You do have the cone waypoints still. That's all you have. Now, with GPS, you can do that already with GPS. That would be the 3 waypoint challenge. So the new challenge is no GPS, but it also kind of assumes you're doing a three point challenge also. I'm just trying to talk about the guys that are, pushing the envelope. Not, I'm not there
Oh, yeah.
yet, so I'm
Yeah.
not. But I'm just trying to make sure we don't run out of top end.
Yeah.
And
Last time I bought only found one cone, so I have some work to do before I'm up to the no GPS challenge, or the no waypoint challenge.
yeah, okay. But I will say this, that the whole idea of this is that if you get 1 point, you get a mug. So all you have to do is get close to a cone. You don't even have to.
So if we have, like, my robot has a GPS, but it plugs into the main board. So if I unplug the GPS and do a run, that can count as a no GPS run?
It could, but you can't do a recording. Otherwise, you can't record the run. That's why the robots are not allowed on the course in the first point.
Right,
place.
but you're allowed to do 3 runs. So you're saying you have to do all 3 runs without a GPS in order to get that?
No, I don't see that, John.
Okay. I have no intention of doing anything like a recording per se, like, a memory between runs.
Yeah.
I'm thinking more, it's really easy to turn GPS coordinates into XY coordinates
Right.
on a grid. The math for that is really easy. So given that you have the 3 GPS coordinates of the cones, you can feed those into the robot, and even without a GPS sensor, as long as it knows which of those GPS coordinates it's actually at right now, doing the math to do the conversion is easy. And then depending on how good your dead reckoning is.
Right. I think that's the whole key. It's how good is your dead reckoning?
Yeah.
If you get, I think David could do this.
Yeah,
Oh, yeah.
clearly.
Okay. So I'm just saying, we're going to throw that out there, and that'll be added to so there will be some modifications to the rule set this year. But they won't change anything. Who knows? We might even up the weight limit to 70. We'll see.
I like it.
So we'll see what happens. Okay.
Doug, as long as we're on the subject of rule modifications, I was thinking of one.
Okay.
It kind of bothers me how subjective it is, the rule about the cone moving. So,
Oh God.
yeah, and I understand this is to have fun, but if you touch the cone, it's going to move a little bit, and it kind of bothers me that the thing's subjective. So here is my suggestion: tennis ball, and let's see, can you see the cone here? Yeah.
Yep.
Yeah.
So if the robot does that and the tennis ball falls out off, that counts as moving. If it can touch it without the tennis ball falling off, it's not moving.
I like it. That's great, Ted. I had not even thought about that. Okay, I'm going to write.
You can
I'll
push
put
the
that
cone
down.
a long way with a tennis ball still on it if you just do it slowly.
Well, if you're slowly pushing the cone around.
Yeah, not on a rough surface, you can't.
Yeah.
Yeah,
That's a great idea.
Yeah,
It's like
yeah.
cricket. In cricket, if you knock the bail off the wicket, the batsman is out.
yeah.
Yep. So yeah, that makes it subjective then. The tennis ball either falls or it doesn't.
Okay. All right.
Yeah, I like it.
What happens if the robot holds it in place on the cone?
Okay.
Well, if your robot's that advanced, it should get extra points.
Okay.
I'm still gonna steal the cone and the ball.
As long as the ball doesn't fall off, that's good for me.
Okay. I guess I could say that you can't touch the cone, touch the ball. That would be okay too,
Yeah, there
right?
you go.
You can't.
Oh, so now we got to balance the cone.
Okay.
Can we spray glue on the ball and the
Thanks.
cone before we get near?
If I knew, Kareem, I know how Kareem would do it. He would reach down, and as he approached, he would come down, pick the ball up, and lift it. Then he would bang the cone all over the place, and then he would find the cone again and put the
Right.
ball back on. We're not going to allow that. But anyway, okay. So
What about if the robot drives up to the cone and then whacks the ball like a baseball to knock the ball to the next cone?
yeah, I'll give you that one. Okay. So thanks, Ted. That was an excellent suggestion. And it does take some of the subjective nature out of the rule set. That's something that, yeah, it's always been kind of a little bit weird. Okay. That's all I had.
Doug, that's a great discussion on Robo Columbus. But can I follow up on the monthly meeting review and
Yeah.
in particular the topic about monthly meeting talks, because I have a problem now with no monthly meeting speaker for August. And so I'm wondering if, those topics that you mentioned are all good. I love them. I'd like to add or throw out the idea and ask what people think of another topic, which would be an introduction to 3D CAD design using modern 3D modeling tools for 3D printing. So taking all the way from the concepts that these tools are built around to using them in a general sense, not focused on any particular tool. But it sounds to me like they all have pretty much similar capabilities through to where you can export it to get printed and where you can get it printed. So kind of like a counterpart to Brady Pamplin's talk, where he showed how you can take a schematic to PCB and get parts for $2. So anyway, throwing that into the mix, but asking the group perhaps as a whole, if there's any chance we could come up with something for an August monthly meeting talk, because if we can't, I'm sort of wondering what to do. Maybe we cancel the meeting, or not sure what.
Okay, well, I'm going to go out on a limb here. We do have I use, God, what is the name of that thing? Design Spark Mechanical. So I don't know if there's anybody else who uses that. So I don't know. I feel comfortable enough with Design Spark Mechanical to show how quick ways to use it for people. They do have a free version, and then they also have another version where you pay $12 a month, and you can cut it off. You're not committed to. Otherwise, you can basically turn it off and turn it on if you want to. But I don't know let's first say what did people use? I mean,
I don't think that Paul's question was about a particular design tool. I think it was about the concept of how you have to redesign for a manufacturing method. And in this case, it would be 3D printing. And I know my team does that all the time. Right. And it's very, very, no, I'm not going to do it because the timing is bad for us, or for me, for August. But it's, whether we're doing like CNC in aluminum or CNC in carbon fiber or 3D printing. And then when it comes to 3D printing, you have to take into account what your printer's characteristics are, what the material you're choosing is, right? Things like how it behaves under different interlayered adhesion, how it bends, depending upon, and there's like multiple materials that we work with. And we have a bevy of choices of things that we do that are like tweaking our designs so that they will print and then work successfully in the material of choice. But it's a very recipe oriented thing. It's like, I think that there are some general principles that can be conveyed about it, but for really successful designs, you sort of start tuning. Like we do a lot of stuff in nylon, right? For mostly rigid parts for a variety, but it might be for different reasons, right? It has incredible in toughness and interlayer adhesion. It won't shatter, but it will bend and deform. And I think John
It also
pointed out that
shrink.
it'll shrink or it'll swell. It does it in our experience. It doesn't really swell when it absorbs water, but it does change its toughness characteristics, right? And just like how brittle it might be and things like that. And sometimes we actually print wet on purpose because that makes it bubbly and it makes it incredibly strong interlayer adhesion. And they just, there's certain, but it creates a rougher surface. And so if you're using nylon for, say, the slippery characteristics that it has, right, because it makes great bearing surfaces as well, then you don't want to do that. So it's like it's a real rabbit hole of a million different kinds of things, and I don't know how to distill that into something of general interest. And I don't know how to I also wouldn't want to give somebody a false sense of comfort around, like, to me you have to be very again, you have to be very dialed into like how your printer prints, like, and how your slicer works. And it's like there's so many variables that I wouldn't want to give somebody the feeling that it's easy to start going down this road. And I don't know how you do it to explain to somebody who doesn't have a 3D printer, right? Because of the experimental nature of it, you have to be able to experiment with it. So like what I heard Paul propose was about like how to design something for being sent off to like a service, right? And there, things like how your holes infill and things like that might vary from one printer to another, and you don't know what the characteristics of their printers are going to be until you've tried them out a few times.
Yeah, and I was going to say that even the CAD programs, even if you decide to limit it to just, okay, here's how I take an idea, a picture, and turn it into a part on a CAD program, that the reason I use Design Spark is because it's the way I think. Okay.
Sure.
But it is definitely extremely different from FreeCAD or Fusion 360, or though I've never used it. I think I've had some temporary license on SolidWorks. All of those are really way different, and a lot of them, the more money you pay, the more fancy stuff it can do. And a lot of the fancy stuff you might not need. So at least, especially when you're beginning. And so all the reasons you were talking about that, the dimensions, definitely you have to know your printer. And the additional slicer parameters you were talking about, I didn't think Paul meant to go into slicers, because that's another that's another complete ball of wax.
You can't avoid that if you're talking about designing
No,
for a manufacturing method.
right. But if you're just talking about, okay, I want to make a part that goes over here, comes up over here, attaches with a couple of screws, you don't need that.
You know,
that's-
you still need to be very aware of like what surface is going down on the build plate, where the
Right.
layers are.
Okay.
That
Yeah.
kind of
Yeah. You're
that kind
talking
of
about,
thing.
yes, because all 3D printers have a strong axis and a weak
Orientation,
one.
yeah.
Yeah, and a weak one. But I guess the question I'd want to ask first is, if I've got some pictures in front of me, if everybody who uses a CAD program right now, who knows something about a CAD program, can make their own 3D print parts on it, raise their hand. Okay, so, and I know Ray can too, so even though he is. So the question I have is, maybe that is not as good a topic as everybody's already wandered down that path to the level that they need.
I would disagree. Designing 3D parts on some sort of CAD process, I've tried it several times. I've muddled my way through, but I'm nowhere comfortable doing it.
If you're talking about beginners too, I mean, Tinkercad is, I'd say, an excellent tool for beginners doing 3D printing.
I didn't particularly like it, but
Yeah.
I wasn't in. I was already down the path before I got introduced to Tinkercad.
Yeah.
I'd say the 3D, the one that Doug is talking about is just really feels natural.
Yeah. Yeah.
I think I tried to work on this thing on OpenSCAD and just the chassis, like never mind the wheels and gears and anything. And I still struggled at it.
Yeah, that they use it uses a constraint. Otherwise, items are constrained to shape them, and that's why I like designs. Okay, I'll tell you what, Paul. I can't be a presenter for a big thing like Kareem was talking about. No, I don't even think I've got that skill. But Mickey, there is a free level, but I can take the free level and show people how to make some quick parts. Okay, and then we can talk about some of the basic things like orientation that Kareem mentioned. But it won't make you an expert, but it might help you over that initial barrier. And it probably
what I thought would be good, Doug, is for beginners, how do you get started? Because I'm about where Pat is. I've thought about it. I've taken the tutorials for Onshape, but I'm like, okay, I learned a lot of concepts there, but it'd be good to have someone who's actually done it. Talk about some of the things you guys have just been talking about.
When's the meeting?
it's
The 27th of August.
right.
August 27th?
Yep.
Yeah.
Is that the third Saturday or the fourth Saturday?
So it should be the
Fourth
fourth.
Saturday.
Okay.
It's always the fourth.
Oh, it's the fourth. Yeah. Kareem, I'm kind of surprised that you're saying.
I'm sorry. Let me correct myself. I misspoke. I was thinking of July.
Yeah.
It's actually the 24th. The fourth Saturday is the 24th of July.
Oh, yeah, that's right. I forgot. Yeah, I'm changing my page right now.
Yeah.
I would think, as opposed to what I think I heard Kareem say, that you're trying to design for manufacturability. I mean, most of the stuff that I would think most of us do are, we use 3D printers because, it's not like we're going to make an injection molded part or something. That could be mass produced or manufactured. It's kind of a one-off, I think, more, at least for me anyway.
Yeah, right. And so I need to make a bumper. for Mobot, for Robo Columbus. Okay,
Yeah.
so how do I do that?
Yeah. And I think the thing that you guys have to remember as well is, what they do for FIRST Robotics is, I mean, that's a rough and tumble, fast paced, everything's going nuts all the time kind of competition where everything has to be built to the nth degree. Most of the robots that we build at a hobby level do not need that level of robustness at all.
Right.
They don't weigh that much. Like I look at this robot, this thing weighs 300 grams.
Mhm.
It doesn't need that level of engineering put into the design.
Right.
In terms of how you print it and that sort of thing. A lot of the parts on this I printed in a way that's convenient, and it has nothing to do with how strong they are, because it just doesn't matter at this level. There are, certainly for this robot, I've taken some of that into account when I design some of the parts, like the roll bar, for instance, because it has to be strong, but other parts, it just doesn't matter. So
Yeah,
you
I
can,
would agree with you, John. I have a hard time unwrapping my brain from
yeah,
the performance, the characteristics that we require, as opposed to what I generally consider like decorative printing,
yeah. Well,
right?
and,
Where
and
you're
there's,
more concerned about just how well will it print.
well, yeah, and there's a world of difference between the super high performance level and, I mean, decorative. I do almost nothing decorative, but I'm definitely in the middle for most of the stuff that I print. It's very functional. I drill and tap holes and make things fit and attach parts together and stuff like that. But it doesn't have to. The robots that I build, at least, are light enough that it just doesn't matter that much. So I think it's a really good idea what Paul is suggesting in terms of, and I brought this up a couple months ago as an option of, how do you design CAD models for 3D printing, and thinking more along the lines of, at the sort of the beginner level of, not so much how do you lay it out on the printer bed and slice it and all that stuff. That's a whole nother issue. But how do you actually turn an idea into a CAD model, into an STL file, basically? And I think that's a really useful skill to have for, whether you're doing
Yeah, but
machining
what
or
you,
3D printing.
what you're saying, John, is much more along the lines of what I had in mind, and like some concepts that I ran into in the online training, were the concept of extruding a 2D sketch into a 3D object, and the concept of an assembly where you put multiple parts together and you can watch them move with each other, as opposed to the parts in a model that are kind of locked in place and static. Those kinds of things are like,
Well,
oh, like the
assemblies,
windows.
Paul, assemblies are first of all only available on certain tools, and in the second thing, that's, I would call that an advanced topic.
Yeah, you don't
Okay.
need
Okay.
assemblies to do most of the stuff that we need to do. I do them on occasion because I want to see how moving parts interact, to make sure that I have clearance between things and stuff like that. But most of the time I don't use assemblies either, because it's just too
Okay.
much of a pain to edit parts when you have assemblies.
Well, Doug,
Yeah.
I put together some bullet points that I thought. I mean, I'm not competent to speak on this, but if I were, knowing as little as I know, it would, you would wish to tell me. For doing slides, obviously the presenter has full editorial control, but I'll pitch in and help with that if you would want that.
Well, I think there's two possible approaches that we can do on this. One, you could have John give a build a device on Onshape, just maybe your bumper. We'll take your bumper as the. Do you have a sketch of it in your mind or anything?
I can make one easily enough. I sort of
Well,
like
well, I'm
having it
just.
there. Something I imagine, yeah.
Yeah, okay. Well, I'm saying maybe you can make the bumper, and then John can do it in Onshape. Okay. And I would be willing to do it in Design Spark Mechanical. And, because like I say, different tools are going to look different to different people. I'll be quite honest. Like I say, there's some CAD programs I just can't stand. And there's others that I think are just like David said, it's just the way, it's just normal, just makes sense. So,
Sounds like an interesting idea, sort of a three-way collaboration between John and Doug and myself to try and.
well, you sketch out
bring the
a rough bumper. Okay. That's your
Okay.
whole input,
Okay.
How many parts does your bumper have? We're not going to.
Two.
Two.
A moving bumper and something to hold it.
Okay, so 2-part bumper. Okay, and John,
Are you incorporating a switch in or two switches into it, or?
we're not going to.
Yeah, switches would be additional.
Yeah, but we're not
they
going to
wouldn't be in the model.
Yeah, we're not going to put them in the model, and we might not. We're not knowing dimensions and stuff. Unless you mark them on the drawing, and then John, that sounds like something that wouldn't be that hard. We'd like to have it ahead of time so we can not look like, oh my God, what did I do there? And we can both step through
I
it.
can get that in the next couple of days to you guys.
Huh?
Would that be in the next couple of days to you guys?
I'm sorry, I can't hear you, Paul.
Next couple of days. Can you hear me?
Sure.
Yeah, that's fine. Yep. Okay.
Yeah, I can't guarantee that I'm available on the 24th right now. I got to talk to my wife because her brother's coming to visit at some point around there, and I don't know if it's on the 24th or the 26th or when he's showing up. So,
you could do since you're going to be remote anyway, John. You could just do
yeah, I mean, I could probably do a half hour or an hour or something like that without any trouble.
Well, no, I mean, even you could just make a movie.
Yeah.
Just, and record.
Yeah, that's true.
And talk through it.
Yeah, I like doing that stuff live though. It's a lot better.
Yeah, I agree with you.
I felt it would be timely for August because people are going to, beginners at printing like myself, are going to be wanting to make stuff in this time frame for Robo Columbus.
Yeah. No, it makes sense. Yeah, and for people who are asking, Onshape is completely free for hobby use, including almost all of its advanced features. Certainly all of the advanced features that you would want to use for doing this stuff. It's all there.
And I think one of the things that, people are doing, just starting out in 3D printing, Thingiverse has like the world of designs, you think somebody's done it and you'll find it on Thingiverse typically. And so that's where, in a lot of cases, you can take what someone else has, had done and modify it to, fit your needs or the way you want it to work or function. So.
Okay, folks. I just dropped the link in the chat. That is competitive 3D modeling. Teaching Tech, Michael over there has his Too Tall Tobin something, and how it works is that you bring whatever tool you want. They throw up a design spec on the thing, and you get to model it. And the guy that turns it in, person that turns it in the fastest, and because they have you spec a material that it consumes a certain number of grams for the object, that's how they determine the winner of it. Fastest, and
actually make it the way it's been spec'd by, they're using volume, like naked Archimedes, that kind of stuff on the thing. So there you go. Get your skills together, roll up in there and see what you can do.
Yeah. As an addendum to what Karim said earlier as well, with the whole 3D printer and sending stuff off to China and whatever, I'll give an example. This robot that I designed and built a while ago, this base, the base part here, the bottom, not the stuff above the black line there, but the base that holds the battery and the wheels and all of that stuff. I created and printed 6 versions of this before I got exactly what I wanted. You almost never get it right on the first shot, and you almost never get it right on the second shot, unless it's a really simple part. But for complex parts that have a lot of fasteners and a bunch of boards and things and holes and you're holding motors and batteries and stuff, you're going to take half a dozen times to produce this. And if you have to send it off for a week to get it printed, every time you do that, it's going to be a really slow process. For simple parts, it's different. But even then, I'd want to prototype them first on a local printer before I send something off to China to get printed.
Fair comment, John. But what really got me going along the idea of, hey, design a part and send it off to China, like Brady's PCB talk showed us how to do, is we had a little discussion on Discourse about how cheap stuff is to print. And John, you showed that you were able to get the URC watch case printed for $3 and
Right.
get a part back in 2 weeks. And
Yeah.
I was like, oh wow, that's fantastic. That is really comparable to Brady's 5 boards for $2 kind of model, and very accessible to
Sure.
people who don't have a 3D printer and don't want one, frankly, like myself.
Yeah, but the difference is PCBs are really hard to build properly yourself. I mean, there are tons of techniques for doing it, but if you want a double-sided board with through holes and vias and stuff, it's
Absolutely.
almost impossible to do yourself.
Absolutely.
I can print the case for this on my printer for less than $3 in material in about 6 or 8 hours. And that's a bit of a difference from 6 or 7 days turnaround time when you're trying to design a part, especially when you need to go through 4 or 5 iterations. That becomes a month and a half for you, and it becomes a week for me, kind of thing. So it's from that perspective, when you're doing rapid prototyping, which is what we do when you design stuff in 3D, you're doing prototyping. Don't ever kid yourself. You have to have that kind of turnaround because it just takes too long otherwise.
I agree.
I see.
And for $150, you can buy a 3D printer. That's reasonable.
Oh.
I mean, it just doesn't make sense not to own a 3D printer anymore.
Oh, really?
Yeah, I mean, it's, if you just watch the Micro Center sales, pick up one of their what do they call them? Reality
3D renders.
3 V2 or one of their AT. There's
Yeah.
there's a whole bunch of them. And
Yeah.
they're so cheap.
You're not going to print ABS on it, but if you want to
Yeah.
print PLA and maybe PETG or something like that,
But
you
I'll tell you what, I've had a lot of success with PLA on most parts. There are some parts that need ABS or something similar to it, or nylon, but they're really pretty rare. And
Wow, so maybe this is an element to bring out in the talk, is the different options, including buying an inexpensive 3D printer and giving it a whack at it yourself.
mhm.
Yeah, Mickey, if you really did want to spend $1,500 on a printer, that's what you're expecting, which you can do. Right now, the Crowley's got one called the K1, which is really good, but the big bad daddy of them all these days, and for us, not not for really doing it for a job, is the bamboo X1C, the X1 carbon. That thing comes with $1,500. You get a 4 different colors of filament, multi color machine. The thing goes at 500 millimeters a second. It'll do a benchy in less than 20 minutes, and all that kind of stuff. It's just simply amazing. And if you don't want to spend all of that, you can spend about a third of it for about $600. Same plate size, and get the printer I've got over here, which is A1, not an A1 mini, but an A1. You're printing some stuff, but it's still a very capable printer, and it's just dead simple to use.
Which model is it?
The model, the X1 Carbon, is the $1,500 one, and you got to get it with the AMS though, the automatic material handling system. And they sell them in combos all the time. If you don't want to spend that much, for just under $600, you can get the Bamboo A1, not the mini, just the Bamboo A1. Yeah.
Bamboo Labs.
Yep.
They've got an X1 series.
Yeah, the X1 is bad to the bone. It's pretty high. It's the higher dollar one. The X1C is their Cadillac currently.
But you know, I have two Crealities which I've been using for years, and I got a big plate and a small plate, and they do. You know, if you're making parts for these robots that y'all you're using, and you only run them once, like in your competitions, that PLL hold up for like 15 minutes. You know, but if you're going to run something every day, all day long, you don't want PLA.
Well, I don't know. Like I say, I have a lot of PLA parts and robots.
Yeah.
I mean, it depends. I'm not saying it's necessarily ideal, but I'm trying to tell you, if you have no printer, you don't know how to, never done any 3D printer, I would say, a Creality, highest model you can afford, and just get PLA. And some of them can do ABS, but the problem with ABS, you might not want to do ABS. There are other materials that might give you everything you need. But the intent is you want to have an enclosure. If you're going to do some of the super hot ones, you want an enclosure.
That's what I was saying, Doug, is I've used the PLA and PET-G for years on this kind of stuff we do.
Yeah.
Yeah.
So maybe in summary, the advice here is to newcomers is find a way that you can get someone, either your own printer or someone to print. Like Mickey has a local maker shop, and my local public library has 3D printers, so I can just walk around the corner and drop off a design to be printed. So maybe this is like a part of the wisdom of you experienced guys of, look for something, look for a quick turn solution.
Yeah, and the thing is that if you have a cheap, PLA printer, that allows you to do your prototypes. And once you've got it to what you want, then you send it off to China and get it printed in nylon on an SLS printer or whatever, and you get an engineering part that will last, forever or whatever, kind of thing.
Or
so
go to the maker space and use the poly printers. Those will do ABS all day, I think. So
Yeah.
Yep.
Sure.
We have 2 bamboo rays. Well, now they have 2 bamboos there.
Oh, they do now? Yeah.
Mm-hmm.
The other thing to consider with that is if you do print on an inexpensive printer, your tolerances won't be quite the same as the expensive ones. So what fits when you print it may or may not fit.
Yeah, and that's something you have to learn by doing. So I know exactly all of the tolerances of my 3D printer because I've been printing with it for like 9 years. So designing parts and stuff. And if you're sending stuff off to China to get done, you're going to get back a part that's going to be subtly different. I mean, the overall dimensions are going to be the same or close to the same, but it may bulge a little different. The holes, they're going to be in the same place, but they might be a slightly different diameter or whatever. 2 parts might not slide together exactly the same way. But that's you basically have to characterize the printer by experimenting, and once you've got it characterized, then you can allow for that in your CAD model such that you produce a part that'll print.
Yeah. Okay. So Paul, to summarize, okay, for the August, we'll have 2 presentations, one by John, where he'll take your bumper and design it on Onshape. Okay. And one where I'll design it on Design Spark Mechanical. Now, in both cases, we're just going to keep it simple. And the intent is to give people who are beginners the chance to see the process of turning the paper into a part. Okay. And
Yeah, that's fantastic, guys. Thank you.
okay.
Okay, I'll be in touch with you guys offline with a drawing of some kind.
Sure. Just buzz me on Discord.
Yep. Thank you. Hey, 2 problems solved in one discussion. So thank you very much, guys, for entertaining this discussion, because our monthly meeting is it's valuable time for a lot of people, I think, and I really appreciate helping getting some content organized for August, and in September. Hopefully, we've got John. I'm sorry, Gibson, Scott Gibson on JTAG debugging.
Well, thanks, Paul.
Thanks, guys.
Next up, I believe, Doug, I guess you're finished.
Yes, I'm finished.
Next up, I guess we have John.
All right. I just wanted to show a couple things that I bought. Waveshare makes some really interesting stuff. I ordered, they have this little USB dongle thing called a Geek, and they have 2 versions of it. They have an RP2040 and an ESP32S3, and I ordered the ESP32S3, and they sent me an RP2040, and so I complained, and then they sent me an ESP32 one in addition. And so it's basically it's a USB dongle with an ESP32S3 and a little LCD screen. And it's like a 320 by something, 135, I think.
Oh, yeah. That's,
240 by 135. And it's a 65,000 color screen. It's got 16 megabytes of flash and I think it's got 4 megabytes of PS RAM. So it runs MicroPython really well. And I'm just starting to play with it now. But the cool thing is, of course, when you plug it into your laptop or whatever, you know, the way it plugs in, the screen is facing up. So this would make a really good URC dongle for a PC. So you can basically not you know, it's not a touch screen, you can't interact it, but you can build Python scripts running on your computer that you can then send effectively over a serial port to the ESP32, and then it can broadcast those over ESP Now to your robot. So that I built one of these kind of on a breadboard, you know, with a tiny Pico ESP32 and a little LCD screen, but it's kind of big and crude and whatever. So I think these were like $12 or something Canadian, or $15. No, I got it on Alley, very cheap. And it's got some plugs on the side here. One of them is for a UART. It gives you power, ground, TX and RX. And one of them is just 3 GPIO pins, and one of them is an it's not power ground on the UART. They just give you ground and RX and TX. 3 GPIO pins, and then an I2C port with power and ground. And they give you the little wire they give you the little wire dongle things that plug into it with those funky
DuPont. Yeah.
DuPont connectors on the end.
Wait, so nothing.
So yeah, it's a really nice little setup. I'm really impressed. So I'm going to start playing with it and see, you know, so the real thing that I want to use this for is doing what I call OTA updates with the robot. So, you know, I've got it like this robot here has an ESP32. It's the only microcontroller on the robot. So the idea is that because it's running MicroPython, the code that you're running is in text files. And when MicroPython runs, what it does is it compiles those into bytecodes in RAM, and then it runs the bytecodes. So the source file is still there on the drive, built into the, you know, in the flash, but it's not using it when it's running the program. And so you can have a little section of the program where if it gets a specific ESP now command, could say, oh, okay, I'm going to start sending in packets, because you have to break it up into 200 or less than 250 byte packets. So you build a packet structure that can handle binary data, and you chunk the source file in packets and send them across, and then it receives them on the receiving side. And because most of these ESP32 MicroPython boards, at least the ones that I get, have lots of RAM, you can just put it in a memory buffer, and then when you're done, write it to the file, just overwriting the original one, or maybe back it up with a backup name and then write it again. Or you can, if you don't have that much RAM, you can just write it as a stream directly as you're getting it. And yeah, so that would allow me to update the code on the robot without needing to plug into USB. And then of course at the end, once you've done that, you just reset, you know, you can do a reset in software, machine.reset in Python, in MicroPython, and it'll start running your new code, which would be pretty cool.
John, can you drop a link on that one? On
Sure.
The page?
Yeah, I've actually got it right here.
I did notice that on Amazon as well. I think 2 days.
Yeah, I
20
think
bucks.
it's a lot more expensive. Right? Yeah, it's $12.99 US. Sorry. So on the Waveshare site, I don't remember. Let me check in my Alley account and see what I actually paid for it. Yeah, I paid $14.15 Canadian, plus I guess there was shipping, so it was $21 Canadian, which is about, I don't know.
Similar kind of thing to what John's showing is this M5 Stick C. So it's a ESP32, very similar form factor. On the end, it has a USB-C dongle and a what's that? I2C interface
Grove
form factor.
maybe?
Yeah, Grove
Quick.
interface.
Yeah.
And at the other end, it has an 8-pin header, which brings out 3 GPIOs. And I've used this in a couple of projects. This particular one is displaying the status of the Starlink, and so it's like communicating back to another one of these that's connected to the Starlink router and its battery. So anyway, just to say, and this one's like 25 bucks. So different form factors. This one it's programmed in Arduino, but being ESP32, I'm sure you could load MicroPython into it.
Yeah.
Like you're suggesting, John. So just to back up what you're saying, these are useful thumb-sized computers for a variety of little interface tasks.
Yeah. The main reason why I like this one over that one is because this has a USB-A dongle, so you don't need a cable, you just plug it into the side of your computer. which I kind of like. But yeah, I agree. They're all really cool for different reasons.
Yeah.
And as I say, they make an
And-
RP 2040 version of it as well with the same screen and the same GPIO. It's also, they both have SD card slots as well on the side. So
It depends on what you want to do. Because if you want to plug into a computer, that's a really good form factor with the USB-A connector. In my case, I wanted to interface it to a water flow valve and
yeah,
a flow meter, and or to my Starlink, and so I had a little circuit board with right angle headers that I plugged the 0.1 inch pitch connector on the end of it into. So yeah, different form factors for different choices, but these are neat little devices.
yeah, it's basically like this without the touch screen, with just a non-touch screen.
Yes.
Same concept. This has a GPIO pin connector and a USB-C. Although obviously it doesn't come with a battery. I think yours comes with a battery, right, Paul?
That's correct.
Yeah. Yeah.
Yeah,
So
it's got
these
the
ones,
multicolor, like you said, 240 by 120 or something pixel
yeah.
display.
Yeah, these ones don't have a battery. They're designed to be powered from the host computer. So
Yeah, but good devices for a variety of uses.
yeah.
So, John, you have a method of packetizing your code to be sent over to chop it up into 250 byte chunks, or
I have a method in my head to do it. I haven't actually written the code yet, but I mean, it's basically like what I've been doing with the URC with this thing is I just use JSON. That's not going to cut it for this because you want embedded line feeds and tabs and stuff in the code. So you really have to use a binary packet and not an ASCII, unless you're going to like UU encode it or something, which I'm not going to do. So what I'm going to use is basically the Bioloid packet, the Dynamixel protocol, which is what I use for virtually all of my serial communications. So it's basically going to, it'll have a header, which includes a couple index bytes and the command and the length, and then the actual data itself will be, in my case, I'll probably break it up into 200 byte pieces. So it'll be and included in that will be the 200 bytes plus a counter, which is which packet it is. So this is packet number 75 of the file, the next 200 bytes. And then once I've got them all in memory, I can just make sure that they're sorted correctly and stream them out to the file.
Okay.
Related to that, I think Arduino has an OTA module in its libraries. I haven't looked into it, so it's been on my list of things to try sometime. I don't know if anyone else has tried their OTA code.
I'm sorry, Paul, I didn't hear who you said had that.
Arduino.
No.
That seems kind of strange because with the Arduino, you have to actually flash the chip. So you almost need a coprocessor in order to flash this one, unless the Wi-Fi in the like the ESP32 has an actual second processor, a low power RISC-V core or something. So it may be that they use that to do the OTA. I don't know.
So I thought that they. Okay, I found a link to it. I'll drop it in the chat.
The one I saw for the Arduino was for doing just generic packet messaging, not specifically for updating the Arduino code.
Oh, okay, no, this is specifically for ESP32 boards, and they have a specific OTA flash partition, and they can just reboot it, and the bootloader handles the reflash. So that kind of makes sense. I would be kind of scared to do that, but well. That's one of the reasons why I like MicroPython over Arduino, is that you're just dealing in source files. It makes everything so much simpler. But anyway, that's just me.
I'm quickly becoming convert to MicroPython. Yeah. It's all your
Well,
fault.
I
It's all
just
your fault.
MicroPython's cool. I just dropped a link that not quite sure how it works, but if you search for Arduino OTA, you get a bunch of hits. So about updating using the Wi-Fi and
Okay, this is a more generic method, it looks like, that uses any Wi-Fi connection type thing.
Yeah.
Interesting.
Cool.
Very neat.
Was that it, John?
Yeah, I think so. I'm just I'm building a cable for my front range sensor in the front bumper. This guy here, which is one of these little time of flight LiDAR sensors. So anyway, that's it for me.
Well, thank you, John. Next up, I think we had Ted.
Okay, so yeah, I didn't make a whole lot of progress. I got distracted by life this week, but I did work on my bumper a little bit, so I was going to show that to you. So here it is with the tennis ball, and you can see it's mounted on the robot now, and I can press it in, and it presses firmly without tipping over the cone or knocking the ball off, as long as you approach the cone slowly. So I think I have something that works.
Cool.
And it doesn't push the cone around on the carpet. I did try it on my slick wooden floor, and it did push the cone around on that, but out in the grass, it's okay too. That's all I had. Quick update.
Well, not that I actually planned it, but when my bumper hits the cone on the outdoor contest robot, it seems to like push the other side of the cone in the ground or something, or tip it back, so it can't move it that much. So, but certainly not by design, but that's what it looks like happens. So
I think it's because you're hitting it high enough that
probably
it's rotating it instead of pushing it.
Yeah. So
yeah.
But now you have to worry.
Coefficient of friction on dry, dead grass in the Texas autumn might be different.
Yeah, that's a good point. Yeah.
Probably a lot lower, more likely to slide, but
I don't know.
You get into bumps on the ground.
He doesn't have much grass out there. It's more weeds.
I know but it's it's pretty dry.
But if it's
not that time of year.
Somewhere,
if it's just rained, it could be slick.
That's right.
Dry grass is actually low friction.
Yeah.
Yeah.
Much lower than green grass.
Don't tell me your team has measured it.
Yes, we've measured it.
The coefficient of friction?
Of course they have.
That was too big of an opening, Kareem. That's impressive.
Hey, Mark posted another Arduino OTA for ESP32 link that looks even better than the one I posted. So just as an FYI.
Yeah, it's a much more specific one that uses the facilities built into the ESP32 to using the bootloader to do the reflash. I think what they're really doing is they're basically saving the new .bin file to a flash location and then rebooting and the bootloader points at that one instead of the other one and says we're going to run off of this
Yeah.
instead, kind of thing.
Yeah.
Yep. The one of the things on my bumper, basically the little switches have a built-in spring, but if the spring force is, not enough, pretty much blades of grass and anything else will trip the bumper. So I actually had to stick a little bit of it. It wasn't this stuff. It's thinner and much more pliable to add a little bit more resistance to the spring mechanism, so it wouldn't catch every little blade of grass on its way to the cone. So, and that actually worked much better. So that's a pretty hard thing to 3D print or incorporate into your, bumper.
What is that, Ray? Just a piece of foam?
Yeah, it's packing foam from, all the crap
Just
I
a
buy
white
from China.
closed-cell packing foam type stuff?
Yeah. Yep. It was thinner than that though. It was more like, I don't know, maybe 1/8 of an inch, uncompressed. So, and it seemed to work really well.
There are some really beautiful foams you can get in packing materials. We have a whole box full of different kinds. Yeah, it's great.
Mm-hmm. But,
Okay. Thanks, Ted, for the presentation.
Yep.
And I guess I'm next. I have, as you can see behind me, this is Bob, the robot. Bob is big outdoor bot. And presently with the battery, he's at 57.5 pounds. I think he has 13-inch snowblower tires. Shaft drive inside, shaft gear drive. So left side, right side are geared together.
Well, that's mostly empty, so you got a long way to go on the weight.
I got a long way to go, but it's still right now 57.9 pounds.
No worries. Doug said he was going to update the weight limit to 70 kilos, right?
No,
70
70 pounds, 70 pounds.
Kilos.
add a zero onto the current weight limit, right?
So as you can see, the wheels are geared together. I don't know if you can see them spinning. And so both sides, left and right, are independent of each other. I've got pillow block bearings. I've got flange bearings in there. I've got shaft collars to keep everything from moving around. I've got a couple of motors to mount in there and a battery. The other thing, and that's going to be a little harder to show. So if you guys can see this, I have a retainer clip on the wheel. And so if I pull the retainer clip, now the wheels become freewheeling.
So, but it won't fall off the end of the shaft, right?
I have a retainer, a collar, so it will not
Oh,
fall
okay,
off
shaft
the end of the
collar.
block.
Yeah.
So you
So-
were able to drill holes through those shafts?
Yes, thanks everybody for the suggestion. What ended up working was matte gas.
Hey, wait a minute, Pat. I wanted to ask you a question. So get it up so we can see the inside.
You want to see the inside again?
Yeah.
Or you just want me to move it?
I was wondering how the motors are going to hook up to this stuff.
Okay. So here I got a motor.
Yeah.
It's an RS 550 with a Bainbots reducer gearbox. And they're going to mount on the angled platform at the
You're
front
a little
and the
below
back.
our visibility there.
Do it on the top side.
So they're going to mount up here. I don't know if you can see that.
Yeah.
Okay. And there is a sprocket going to be going on the reducer shaft. And a sprocket. These guys. Little chain sprockets.
Chain
So-
drive.
One is going to be on this shaft, one is going to be on the motor. So it's just a short little section of chain. And the same on the other end. So it'll drive both left and right independently.
The important question is what are you going to stain it with? Surface finish too. Yeah.
Exactly. Surface finish. So that's where I'm at right now. Part of the reason for this is it's not just a Robo Columbus
Well,
robot.
Patrick,
So it doesn't have any suspension, right? That's all
It has no suspension. Build it tough.
well, Patrick,
It has an air suspension. They're called tires.
Pneumatic tires.
Cool.
So even that, one of them had a leak. I
you
had to
doing
figure out where the leak was and reseat the bead on one of the rims.
They're radials.
big and very beautiful looking things that operate very smoothly, Pat. When I was putting that Roborama video together, I was admiring how smoothly and carefully the wooden monster moved. It really was quite smooth. So I was like, wow. And this looks like another of that kind of operate smoothly kind of robot.
It'll have a little bit more backlash because of the pins. The pins in the tire, there's a little bit of backlash between the two wheels. And then the bevel gears inside as well. But overall, I'm not too worried about it if it moves a couple inches and, you know, as we're stopping or something.
But I take Paul's meaning to heart. It's like I'm constantly telling my students to figure out the mechanics first before you figure out how to move them.
Yeah.
Right? Make sure that everything works beautifully from that perspective. And it looks
And,
like
well,
you're
I'm
going in
hoping
that direction.
I've got a few $100 invested in it so far. The motors are reclaimed. Those motors were originally on the Wooden Monster, and they were way too loud for indoors. Planetary gearbox tend to be loud, and so it's going on the outdoor bot. Repurpose them. I bought a battery to use lithium iron phosphate because it weighs 7 pounds instead of whatever it is, 23. So everything I can lose off of it is going to help. And I'll be moving getting ready to start moving some of my controller stuff over.
Cool.
So hopefully in a few weeks, we'll have something rolling.
It's really neat.
Pat,
That's it.
you're starting to talk about using map gas. So how did you sort the holes in the shaft?
Oh, I use map gas. So I think I know. I don't know if it was Kareem. I forget who mentioned it last time. To use map gas to heat up the shaft.
Anneal it?
So I did that. My neighbor had some, so I borrowed his torch and I heated it up, cherry red, and I did that for about the last 1.25 inches in the shaft. Let them cool down. Next day, I took an angle grinder and I grinded a little bit of a flat spot in. And my Amazon order came in with my 7/32 of an inch cobalt bits, and using lots of cutting fluid. I basically drilled out the holes.
It only had to last for 4 holes, right? So,
Well, 4 holes in if I broke a bit. So I bought a spare. So
oh, okay.
I do have a spare cobalt bit, but the other one still looks like brand new.
Oh, that's
worked
good.
out.
Yeah. Yeah, the Harbor Freight, I needed 8 half-inch holes in 1/4-inch steel angle iron. And I thought, okay, well, Harbor Freight, it's got cheap drill bits, and they had some that were on sale that were titanium coated. And I thought, well, I don't know, let's see if this is going to last for all 8 holes. And it actually held up. So.
So I think I'm going to pick up a little bit of aluminum to strengthen a couple of the wood corners on the robot, just because some of it, like the front and the sides are 3/8 plywood, just construction grade plywood, and there's not much meat holding. It's glued, and at this point, brad nailed. And so I'm going to put, I think, some 1.5-inch angle aluminum on the corners and sort of you see down here and then down the angle. Just help stiffen it up.
The split pin goes through the shaft, obviously. Does it go through a collar that's attached to the wheel?
Yeah, the snowblower tires are basically they're a hollow shaft, and I use the 12mm drive shaft because 12mm parts are shaft is linear shaft is way cheaper than 1/2-inch or bigger, lighter, because 12mm is used in printers everywhere, so it's out of China. Same with the bearings, same with all the parts I use.
Yeah.
But I had to adapt. I used some reducers, shaft expanders, to go from 5/8 to 1/2-inch, or sorry, from 3/4 to 1/2-inch. And then I had to go from 1/2-inch to 12mm. So I bought some shim, some 0.3mm stainless shim on Amazon, and I cut it. I wrapped the shaft with it. That's really hard on the fingers when you're trying to wrap 0.3mm stainless shim around the shaft. But I did manage to get it wrapped on there and slid the reducers on, and everything is working good.
Oh, that's good.
Wow, cool.
So that's what I had. Just a little bit of presentation, lots of waiting for parts, and then finally just getting it all together.
Yeah. Do you have K&S in Canada?
K&S.
Yeah, it's a company that makes I don't know, different materials. Like this is several different,
Oh yeah, that's the you can get it at hobby stores.
Yeah. Oh, okay. Yeah. Like this one is multiple, I think 3 or 4 different like tubes that fit within each other. And this is brass, but yeah, they're all stuck together in one piece here. Anyway, same sort of thing. You can get, different ODs, different IDs, and to adapt.
John lives in a bigger center than I do, so he has a supply. Everything I get is ordered.
There you go. It looks like you got them all, John.
Well, I have a bunch of them. I mean, aluminum and brass. These are all rounds. Well, actually, there's a couple flats here, but most of them are either tubing or solid rod in aluminum and brass.
Yep.
Yes, we get these in Canada.
Yeah. You should have bought the whole stand, man, with every little selection of
Yeah, we would need these 70 kilograms if I made that out of cherry steam bent planks.
But it would be gorgeous. A nice
yes.
dark red Chinese lacquer, Ming era. You can do it. A little bit of alabaster inlay.
Exactly.
Your own lac bugs to make shellac,
Mm-hmm.
No, that's about it. I think it's going to get painted with some outdoor paint, and that's about it.
Barn red.
Green or
Barn red. No, snowblower orange.
That might conflict with the cones. You're trying to get somebody else to follow you.
Ooh, there you go. Plus the red probably has lead oxide in it. I think that's where, that's why a lot of barns were painted with red paint. It was easy to make, and
Now you know my GPS and IMU mount is going to be on top of an 18-inch cone on top of the robot.
There you go.
That's it for me. Does anyone else have something they'd like to present? Okay, well, open it up. If anyone has questions or comments, something they'd like to see.
I can
I'll
show
open
the state of my robot electronics.
Absolutely, Mike, go ahead.
It's a real mess, way work in progress. I'm going to take the computer over to it since it's so heavy.
Is it 57 pounds heavy?
No. So
Yeah, what do they call that? Isotonic exercises? You know, you stand there and try to hold your robot in front of the camera, you know.
yeah, so basically I put a piece of cardboard on there and I'm putting my electronics on it. And I got myself a powered hub, and here's the Raspberry Pi, and here's an IMU here, and I'm going to put a GPS here, and that's the camera here. So basically, I'm just throwing the pieces together, and then once I get things working, then I'll try to get good cabling and stuff. So that's where I'm at.
Thanks, Mike. Are you going to be mounting the GPS or whatever higher up on a mast?
I don't know.
I know some of the guys are mounting IMUs.
I'll probably lift it 3 inches, or I'll try to keep it within the cabin of my Jeep. So
okay.
I don't think the GPS needs to be mounted anywhere. It just has to have a good view through the plastic of the cabin.
Maybe the IMU more so than because of your motors. Mine's IMU, my motors, and
my motors are on the other side, but there's a lot of metal around. Yeah.
Oh, is it? Yeah, a little mu metal shielding, maybe.
So I'm not going to put anything down until I understand it. Then I'll make it more permanent. This is way unpermanent. Blue painter's tape and cardboard. Just put things on there so I can play with it.
Mm-hmm.
So I worked on my. I couldn't find my B&O 85. It was hooked up with a cable to a small board with the QT, the stemma QT cable, and I looked everywhere. I finally found it mixed in with some power cords on the ground. It got misplaced. Boy, it took me hours to find that. But I got to go through all my boxes and figure it out and sort out stuff. So
makes me think of that Far Side cartoon where kind of a woman with a big butt is asking, "Where's the little doggy?" And it's it's wedged in her cheek.
Yeah, but I was at wit's end, and then I got on my hands and knees finally and looked under my desk, and there it was, mixed up with the power cords.
Oh, yeah. Man. Well, at least it wasn't the "where's the little doggy" scenario. So.
Right.
Yeah, I've got my B&O 085 on top of the mast here. A little 3D print. This is a carbon fiber pole that I bought a long time ago, and I just 3D printed an enclosure with a cover. I'm using nylon screws to hold it all together, and it's 20, 40, 50 centimeters long, I guess, the whole thing. So it's almost 2 feet up.
Yeah.
Okay. Yeah, it's
hard to say. Going with something like that as well, John.
What's that?
I question going with like a carbon fiber mast of some sort. And I'm tending to lean the other way, either wood, one of my favorite building materials, or PVC tubing.
Plumbing,
Yeah.
yes.
Yeah,
Or
PVC
ABS.
tubing would probably be better just because you can run the wires inside it.
Yeah, you can run.
If I didn't have these, I probably would have used that. I had a box of half a dozen of those that I bought a long time ago for a different project.
Also, PVC is quite easy to replace if it happens to roll over and break.
Yeah,
You know, is just about every hardware store has a 3/4 inch PVC.
yeah.
Yeah, Doug, what you actually cut a plumbing fitting open, right? And like heated it, and what kind of temperatures did you have to do that at?
I just used the heat gun.
Oh, okay.
Yeah, you slice it open with a hacksaw or bandsaw. if you got
John, are those solid?
No, these are
Okay.
really thin wall tubing.
Right. Right.
I think it's like 1 millimeter.
Yeah. You
Thick
could run the
wall.
wires through it.
Yeah, they're
And
1
that-
millimeter thick wall, and they're 20 millimeters in diameter.
I imagine it would take a lot to break that.
Yeah, they're pretty strong. These are the arms off of a DJI Inspire drone. They're big drone, the one that
Big.
folds.
Yeah.
So they're pretty strong. I broke one on a DJI Inspire when I crashed it. We were doing an interesting project, but that's a whole different story. So I bought some spares and whatnot. But
Yeah. If that robot fell over, it wouldn't break the rod. It would just break the 3D mounted.
it would
attachments.
probably break the 3D printed piece, although it's
Right.
pretty solid. I mean, it's ABS and it's held on with machine screws and
Not as solid as the rod.
no, it's not. But it's softer. But it's
Right.
being held in, like it's these, I don't know, 40 millimeters or so deep into this piece of ABS. So yeah, it's hard to say.
Mhm.
I'm not concerned about this thing. This thing I can tip it at 45 degrees and it comes back to it has a very low center of gravity, so I'm not at all concerned about it flipping over. I mean, if my robot gets into a state like that, we're going to have other things to worry about.
You should do the clothesline test where it comes up and catches it up high, like a branch or something.
Yeah.
See if it recovers from being clotheslined.
It would have to be a really strong branch.
It'd be a wheelie.
A park bench, maybe.
Yeah, there you go.
But I'm hoping that the camera will see stuff like that. So. But yeah, I've been working a lot on the software on this thing. I've got the STM32 code talking to almost all the sensors and obviously controlling the robot and reading the RC inputs and stuff. But it's a device now with a control table. So the Raspberry Pi, I'm starting to work on the Raspberry Pi code now to actually talk to the STM32 and get data from the control table and store data in the control table. So I can start working on the autonomous controller code. So that's kind of cool. And I wrote a bunch of a bit more code on the URC for supporting this.
Yeah, I also I was working on my engine controller and I looped it back, at the engine controller, which is a Pico inside the engine compartment. And then I also looped it back in ROS, the signal from the transmitter. I looped it back to the steering and the motor and everything, and it worked. So that was sort of a big checkoff point. Yeah, it can go through ROS and it's okay. Yeah, so things are sort of working. Now I'm trying to figure out the Ackerman part. So
Yeah, it's from my perspective, that's the problem of working with things like ROS, is that you have to, well, maybe you don't have to, but it seems like everybody wants to do planning. And I think personally planning is the wrong approach for this kind of robotics. I think it makes a lot more sense to do effectively real-time one-step planning, which is, you know, like visual servoing and things like that, where the acronym is irrelevant because it's turn until you're pointing, you know, you steer by giving it a turn rate, and the amount you turn is proportional to, you know, your turn rates between -1 and +1, and the amount that the steering turns is proportional to that. And you know, if the thing that you're looking at, say an orange traffic cone, is over on the side of the camera view, then, you know, you set the turn rate appropriately and adjust it as it gets closer and closer to the center. And as long as that's running in real time, there's no reason to try and figure out ahead of time what steering setting you're going to have to set in order to, you know, rotate the robot 27 degrees. It's like turn it until the heading is 27 degrees off from where you are, and then stop turning.
Yes, yeah. So the kinematics don't have to be very precise, because it'll be self-correcting. So I think that's what you're saying.
The kinematics aren't there at all. I mean, it's a form of kinematics, but it's really it's a completely reactive system. There's no decisions on, like, if you look at Bob's robot, and I'm pretty sure he's not using ROS, but as an example, because he only had a 1.5 second sample rate from his camera, he had to take an image, see where the cone was, and then make a decision about where he was going to go, turn the, you know, his tires, and drive forward a bunch, and then he'd get another frame from the camera. And if you're getting frames from the camera at 30 frames a second, you don't need to do that. You're using instantaneous feedback based on the sensors, you know, in this case, your camera sensor, and where the object detection is in the horizontal view of the camera, to decide how much to turn and in which direction to turn. And that, you know, it's how David Anderson does all of his robotics as well.
Yeah. Well, and the GPS, I decided I'm going to try not to use RTK, or and GPS is not very precise.
Yeah.
So you have to basically say, I need to go over where I think it is. And then once you get there, then you turn the camera on, or you start using the camera for cone detection. Otherwise, you're using the camera for obstacle detection.
Yeah.
Right.
Yeah. And I'm definitely going to be doing that. I'm going to be using, there's a class of Kalman filter called an unscented Kalman filter, that allows you to, that works reasonably well for this kind of navigation. And the idea is you basically throw in your GPS readings from the GPS, and you throw in your encoder readings from your encoder, and you throw in your IMU readings from your IMU, and it does a pretty decent job of approximating based on where you were the last time it tried, and you know, where you are now. And so the nice thing about it, an extended Kalman filter, you have to have a linear system, and with an unscented Kalman filter, you don't have to have a linear system. So it works better for this specific kind of filtering with navigation and stuff. And it turns out that there's a really nice Python implementation of an unscented Kalman filter out there. I think it's called PyKalman or something like that. I've got a link to it here. I'll drop it in the chat. Software sensor fusion. Here it is.
So does that assume that you're traveling, you know, that your velocity is fixed?
No, it uses the encoder, right? I have a on the output shaft of my motor, I machined a little brass rod that basically attaches to the output shaft of the motor, where it's got a big pinion gear that connects up to the transmission. So I extended that out past the pinion gear and machined a little tiny part of that brass rod, that one of those magnetic discs that goes onto the back of the these kinds of motors. They have a little magnetic disc.
Right.
And
That's
so
what
I
call
have
it.
encoders specifically designed to work with those that I bought. And so I can slide that, and it's a tight friction fit, slide that magnetic disc onto that little brass rod. And then I have a magnetic encoder right next to it. And that's a quadrature encoder that feeds into the STM32 and uses the hardware AB encoder stuff to do that with a 32-bit timer. And so I get encoder feedback. This machine, it's nice if you've got one on each tire, but I mean, all 4 tires turn at the same rate because they're all locked together with the the differentials are spools, and the transfer case is full-time 4-wheel drive. So all 4 tires turn at the same speed. So you lose a little tiny bit of accuracy when you go around corners, because of course the front tires scrub, but on grass and gravel and sand and stuff, it doesn't really make a lot of difference. And it's just an approximation anyway. So with the combination of the IMU and the GPS, and if the GPS reading goes haywire, then that's the job of the common filter to figure that out and say, okay, we're going to ignore that for a little while and just base it on straight dead reckoning from the IMU and the encoder, rather than and give it less importance because it's gone off, and eventually it'll come back again, and then it'll start using it again, and they do that automatically, which is nice. There's a couple people who have written pretty extensive articles on using unscented common filters in navigating robots, and that are not like not academic papers, but like blog posts and stuff. So it's I thought it was really interesting. Apparently you have to build covariance matrices to use these kind of filters. And I don't have a clue how to do that, but my son is a math head and he does. So I said, go learn about common filters and tell me how to do this. And he said, okay. Yeah.
I've got
Once in a while, I try to figure out common filters, and I don't get very far before I get lost in all the math. So you're lucky to have someone to help.
Well, the implementation is there. It's just a question of being able to give it the right inputs.
Yeah, it's those
and that's
covariance
the hard
matrices and the input matrices that get me.
Yeah, me too. Sorry, what were you saying, Pat?
So I wasn't sure if you guys were done. I was just going to mention, I picked up one of these. I don't know if you guys can see that. It's a little Grove.
This guy.
Yeah, little Grove Vision AI sensor.
Oh yeah, yep.
The V2, the newest one they got. And I've been doing some testing with it. So I tried the traffic cone setup they had without any luck. I'm not seeing any traffic cones at all on it. To test that the sensor was working, I loaded another one. So I loaded the rock, paper, scissors image into it, and it is working. So I know the sensor is working. So as you do the rock, paper, scissors, it picks them up right away.
Yeah.
So it's doing a pretty good job. I have a traffic cone that I've been testing with. So I have this guy I tried, just a little orange birthday cone type thing. But anyways, the backside sort of looks like a traffic cone. And no luck. So I have a regular traffic cone I brought in and pretty big, and it still wouldn't recognize it. So I don't know if it wouldn't recognize it. I was testing it in my living room with my living room background. And who knows how AI works, that possibly it doesn't recognize anything in the background, so it won't pick it up.
May have to put it out in the street, huh?
Yeah, well, that's I may try it like just out in the yard in the grass and driveway, something like that, to see if it picks it up.
It's probably lighting. It's probably more to do with lighting than anything, because those things tend to be, you know, unless they're trained on a really good set of images, and the really tiny models usually aren't. And the thing you got to remember is this thing doesn't have very much memory.
Yeah.
It's only got like a megabyte or something. That your model has to be smaller than that, or 2 megabytes. So it's it doesn't have a lot of memory to run a model on. I mean, it's got a decent processor on it, but there's not much memory in there for the actual model. Bob and I spent some time trying to get his models to run on it, and we couldn't get anywhere with it.
Okay, you've tried with Bob's models?
Yeah, we couldn't get it to work at all. Like not that it wouldn't detect the cone, we couldn't actually get it to work. Like couldn't get his models working with that particular module. So I'm going to run.
That was one of the things I was going to try. It was cheap enough. I think it was 32 bucks Canadian.
Yeah, yeah. I'm going to the Oak D Lite, the software library that comes from Luxonis includes a model called Cone Slayer that is a very well trained on several thousand images of cones, traffic cones of various kinds and stuff. So I'm definitely going to be trying that one first before I bother doing my own setup.
That's about it for me. That's everything I've been playing with. Pretty quiet out there. Nobody's frantically building for Robo Columbus.
Everybody's frantically building. What
what
time are we thinking of? What time are we thinking of running our competition? Like what month?
I was going to leave that to depending where we go. If it's Hamilton area, I was thinking, you know, at the latest, late October.
Yeah.
Even early November might be okay. We might not have any snow there. You know, if they do it around the same time that the DPRG folks do, it would be around the second weekend, around the 13th or 14th of November. And that gets a little iffy up here, that we could wake up with 4 inches of snow in the morning.
Yeah, I mean, my car will go through 4 inches of snow without any trouble, but I'm worried about the electronics getting wet. So
I think this thing will go through 4 inches of snow.
I would think so.
It's got 4 inches of ground clearance, so.
Ah, well, there you go.
You could make a little mini plow for the front of it, you know, just clean up your sidewalks and stuff.
I've actually got 3 inches of ground clearance under the center of this one, so it's
not bad. So I thought possibly mid to late October would be reasonable. Yeah. And I don't know if we could get somebody to join us from DPRG, or do we turn around and do it on let me pull up a calendar just as a suggestion. Let's say the 26th of October, which would be DPRG Saturday meeting.
That would work.
So I don't know if they would entertain that, but it's possibly an option.
Yeah, I know Norm said he's not interested for this year, but maybe for next year.
Okay.
he's interested in coming down from Smith Falls to do if we do this next year.
I think we have a date already set for the Dallas the River Columbus.
I thought we did. Yeah. I don't know
I
though.
thought we did too. I'm just looking, taking a quick look.
Doug, any input on that?
Yeah. So, I see. The web page says it's the second or third Saturday of November 2024. Exact date TBD. Doug, are you still on the line?
Doug is, but he's muted.
He may have stepped away.
Yeah.
Yeah.
So that would be the 9th or the 16th.
I was sort of thinking that. Well, let me just take a look at November's calendar. But if we call that the November meetings, but I realize 2, 3, 4. That would be November 23rd. Would be the November meeting date.
Yes.
But like to hear what Doug has to say about that.
But I would like to stream the one in Canada. Check it out.
Yeah, for sure. We need to record it and put together a video of the runs and.
Yeah, well, I would like to record it, whether it's just on our phone or whatever, into Google Meet, so that we could, at a later date, incorporate it and play it back. I just thought that, it may be a good meeting topic for October if we don't have one.
Right, you guys up there have a different weather considerations than we do. But I think it's something we should discuss with the people who would be competing here in Dallas, and particularly with Doug, who is sort of like our competition master. I wouldn't like to make that decision.
Yeah, Doug has said we could run the contest early in Canada. Because so, like, for instance, last year at Halloween, where I am, Halloween morning, we woke up to 4 inches of snow. And by Halloween night, there was only about an inch left. But it's still, if that was during the day, we'd be running through snow for a contest. Where Tom and John are, they're a little farther south. And they typically don't get that weather for another month after us.
Yeah.
But anything can happen in Ontario. So
yeah.
Now the
Doug has said that we can do it and record it and broadcast it later during the meeting. But I thought it might be an option to do it depending if you guys talk to Doug, say, hey, do you want to do a October meeting and do it live on a Saturday?
I added a GoPro mount to the roll bar on mine, so I can record from the robot's perspective video of
FPV
of its run.
Nice.
Now the coefficient of friction of snow could be interesting. Might do some interesting things to the white balance of your cameras too.
Yes.
Yep.
Definitely.
Yeah, you got to train on snow background. Yeah.
Easier to spot the orange cones.
True.
Except on Halloween, you do have the pumpkins to worry about.
Yeah.
Yeah. So subject to Doug and others' input, I think November is a good. The Saturday monthly meeting for November would be a good time to do it in Dallas, but I do agree that it probably needs to happen earlier in Canada because of the weather factor, and do like the idea of streaming it recording it, and so we can watch it as it happens, and put it into some kind of like composite video.
Yeah, it's I think it's good. At the same time, it legitimizes our competition. We've got people overseeing exactly what's happening as we're doing our runs.
Oh, you guys are absolutely 100% legit, Pat. I mean, looking at the video that John provided me, it was like, wow, it was great video, and it was like great runs, and I mean, it was awesome. It was really awesome, and that competition that we did, I thought it worked out really well. I was just like really pumped about that.
I was thrilled to have company during a competition, up north here in Canada. It was great. Tom generously provided this house and lunch, and we got some shade in his carport. It worked out fairly well, and I enjoyed it.
Yeah, and it was fun to see all of you sitting around in your lawn chairs watching the TV as we did our runs, and then you did yours, and it was neat.
Yeah, I like the way we did it intermixed between your runs and our runs. It was good.
Yeah, but I don't think it's going to work for Robo Columbus. So let's just plan on separate runs at separately organized times. Stream it, record it, and from Canada, and then do the same from Dallas, and then we'll put it all together.
Yeah, well, that's exactly it. Is we'll have it, and we'll have a final video to go out with everybody's runs. Everybody will know what how we score beforehand.
Yeah,
they'll know what to aim for anyway.
Well,
hey, Doug's back.
One of the things you can do too, if we mix them, like if you guys are streaming at the same time we're streaming, we can mix
Doug,
them.
just to catch you up, the way the conversation evolved was the Canada guys really kind of need to do it earlier than we do because of
that works even better.
And so I'd propose that we do it on the monthly meeting date in November in Dallas, which is the 23rd of November, and the fourth
Week
Saturday.
before Thanksgiving. Yeah.
Oh, it's Thanksgiving on the 30th?
It's the 28th, I think.
Okay. Yeah. Great. That dodges that holiday too. So let's make it Dallas competes November 23rd, fourth Saturday, in place of the usual monthly meeting, and Canada.
Well, you probably got to check with Steve.
Yeah.
Yeah, right now that would be a Friday. Yeah, so he works,
Let me check in with Steve, and I'll coordinate with Steve and Doug, and we'll make a decision on that.
Yeah.
The 23rd is a Saturday?
No,
it's a Saturday.
No, 23rd is Friday.
November 23rd.
Oh, you're okay. Gotcha.
Yeah.
November 23rd is a Saturday
this year.
Yep.
And then we're proposing that the Canadian group does it on the previous monthly meeting, October 26th.
Huh? Do you want to do it that early? Do you guys going to be ready?
Well, we're fighting weather here as well, so.
You're right.
We don't want to do it in the snow, so.
Yeah.
Yeah. I got you.
We'd like to hold off till November, but we don't know where we're going to be as weather-wise here.
Okay, so you guys are going to do it on October 26th, and we'll sit around and watch you guys. And then on the 24th, you guys can sit around inside and watch us.
Exactly.
Apparently, Canadians are afraid of snow.
Canadian robots are afraid of snow.
Yeah.
So let me just ask you guys, do we want to, and this is kind of a question for Dallas part of the group, do we want to dedicate the October monthly meeting to watching the Canadian Robo Columbus runs?
Yeah, I'd
We
like to
could do
do
that.
it.
I'm just asking.
Yeah. So it means that we have to adjust the times because we'll have to figure out when they plan to run, and we'll have to adjust the time to cover that time. Because it's chances are they're not going to be going from 10 to 2.
Right.
Well,
Good
10
point.
to 2, your time is
It's
11 to 3.
Our time, which is fine.
Yeah. Yeah, I think around noon is you know,
Okay.
our
cool.
time, noon or
Later.
So would we
Okay, so
want
you're
to? So we would
So are
want
you
to
guys
have
gonna?
an online meeting then? Would we want to make that an online meeting as opposed to an in-person meeting in Dallas?
we could bring popcorn and view it at the makerspace, I guess.
Yeah, that's what I would do.
Yeah.
Yeah, I think we ought to watch it and we ought to go to the makerspace and watch it.
yeah, on a big
It
screen.
should be an event. Yeah, it should be an event.
Okay.
I think it's a lot
Do
more
you
fun.
think we want to?
It's a lot more fun to make fun of the Canadians while everybody's together watching and eating popcorn.
Yeah.
Well, now the gauntlet's thrown down.
We wouldn't do that. would we?
Hey, Pat, are you guys expecting any additional competitors besides you three? You mentioned at one time there were some people from
There's
somewhere.
a guy in Waterloo who's actually a couple people in Waterloo who are interested. I don't know if they're gonna actually be interested enough to get their robots ready in time, but we'll see. I'm talking to them, so.
Okay,
Well,
that's great, John. That'd be good. I mean, I'm just saying.
So how about for the October meeting, if we have the watch the Canadians compete on video, and then maybe show and tell on Robo Columbus entries, or maybe even put some cones out in the parking lot at Makerspace, and we can have like a practice run before or after we watch the Canadians compete for anyone
Okay.
who wants to do that in the Dallas group.
Well, okay, Paul, I'm going to tell you this because I did that a while back, but I had to do it late at night because these guys, that parking lot now on Saturday is full.
Oh,
You're not it's going to be kind of, you got other businesses in there that are working on Saturday or something. And I'm not saying you couldn't put a cone up and maybe do a straight shot for one or something like that, but it's not going to be as easy as just throwing 3 cones out.
right.
But, hey,
What about maybe putting a cone in the meeting room, and if anyone wants to aim their robot at it and see if they can seek to it and touch it, then welcome to. Otherwise, just like bring what you got, show what you got.
Yeah. Well, I think it'd be interesting. I personally just watching if Pat, John, and Tom make 3 runs, that's going to be pretty much all the time I'm going to watch. Unless Pat's wooden monster, kind of like has a fit and starts burning or something.
Spontaneous combustion.
Yeah. But other than that,
You never know. Some of the bearing heaters may overheat.
Yeah.
Are you going to put that map gas torch, like build it under the robot? Like retro burners, afterburners?
Not at all.
Yeah. But it'd be cool. And if they have some additional participants, it's even going to be more to watch. I don't think you have to do anything.
Okay.
Unless they all decide that they don't want to run for some reason. Which I
will declare that October will be a Watch Canada compete, do their runs, and show and tell our robots if we want to.
Sounds good.
Does Canada have an official, is it a Canada Day? I don't know what you call it. Kind of like a Memorial Day or something like that.
We have our May long weekend is the weekend before you guys. So you're always around the 24th. We're the week before, the weekend before that.
Yeah, it's called, it's Victoria Day here.
Victoria Day.
Oh.
And then we have Canada Day, which is July 1st. You have Independence Day, which is July 4th. Labor Day, we both celebrate. Thanksgiving, as I said, hey, we don't harvest crops in November because they're buried in snow. So our Thanksgiving is in October.
Yeah.
Cool.
So you're ahead of us in everything.
Yeah, including global warming and all sorts of other stuff.
Are you trolling, Kareem?
Yeah, absolutely. That's
Okay.
about all I'm good for.
And now that ain't true.
Yeah. Well, guys, I'm going to have to go. So adios, and we'll see you next Tuesday.
Yep.
Auf Wiedersehen.
Yep.
Sounds
Hey,
good.
guys.
Good night, everyone.
Bye.
See you, Doug. Hey, Pat, thanks for hosting. Much appreciated.
Oh, no
Yes.
problem.
Yeah, thank you, Pat. Really
Great job.
appreciate you stepping in on a